But that's basically as much soil as my colleague Michael has here. You can
Basically
see.
a teaspoonful.
You pop it in the drawer, and then you hit go on your phone.
Well, first you have to put a few details in first.
So Michael, do you want to tell us which details you're putting in?
Okay, let's just go.
So Michael's currently putting in the location of the farm. So he's telling us where we are, because all the results GPS logged and timestamped, but he's saying which is the farm that your organization is interested in measuring at. Then he's putting in information about the soil sample. So for instance, he's giving it a name. He's saying what season it is, what the soil...
Soil moisture, which I put as moist. I put the soil no, I'm going to put it as medium. And it's an arable soil.
Yep.
Yeah, so we're going to start the test. So what it's now doing... sorry.
Yeah, let's turn around so people can see. So you can see here that it's starting to compare it. So you can see it's got a little screen showing it, and we've used an iPad because it makes it easier. Apologies for those of you in the back who can't see it, but there is a little screen here you can come and take a look at if you want to sort of scrunch in, and it's showing what's happening with the device. And basically it's starting to do the test, and it's a 5-minute cycle.
It's testing the sensor first.
It's testing the sensor as part of the first cycle, and then it starts conditioning the soil. So you can hear now that you hear a little buzz. That's basically it's conditioning the soil. It's taking away excess moisture, just making sure that actually it's all right. And it does that for a few minutes to condition it, and then it allows basically the volatiles from the soil to percolate up to our sensor, and that's what's measured over a number of minutes. So I mentioned that we started this back in 2017 with NIAB, and it was their idea to, could you link key indicators of biological soil health to basically smelt? And my co-founder, who couldn't join us today, said I could maybe develop a sensor that could do that. Went away in the lab, and we did an Innovate UK project with NIAB, basically where they took soil samples from various different sites, they analyzed them in their lab for a variety of indicators, and then they did the statistical analysis between the results from our lab-made sensors and the result test that they did. And they found there was excellent correlation with the biological indicators, so microbial biomass, organic matter, respiration. But what we also found was there was actually very good correlation with physical and chemical indicators as well. So water holding capacity, pH, organic matter, were all things actually we found there was still also a very good correlation with. We then started a much larger project, working with NIAB again, but also with Hutchinson's, as well as University of Greenwich and University of Essex and small robot company, to see if actually we could develop something that could work as a soil health assessment product. NIAB and Hutchinson, the other partners, determined what a comprehensive soil health assessment would be, and those are the indicators listed there that I've listed earlier, all the ones that we had. And the idea was to get this to a point where it could be near to market readiness, and then test it, basically see how good the accuracy could be. Could we make this into commercially viable levels of accuracy? And by that I mean that it's equivalent to the accuracies you get from labs. We did work over a number of years to be able to get it to that state, and we found that we could actually get we got the commercial levels at commercially viable levels of accuracy for all of the indicators we wanted to do. The only one that we didn't manage to get done was microbial biodiversity, but that's because we couldn't get enough data for it because it's very expensive, and actually we didn't have enough soil samples at the end to be able to say we've got a good level of accuracy. We're pretty confident that we have, and we've got a follow-on project doing that with Boffin and John Innes Centre, but that might be coming out in a few years' time. But as you can see here now, it's starting to sort of do that Snelling cycle, working through it to be able to provide the indicators in field in 5 minutes. So, I've talked for quite a long time. Are there any questions? Anybody would like to know?
Yeah. What are the 12 things?
Sure. So we provide microbial biomass, respiration, organic matter. We provide pH, pK, magnesium, extractal ammonium, extractal nitrate, and we provide water holding capacity, field water content, and soil texture.
Good.
And total nitrogen.
Is the PK elemental or phosphate content?
I couldn't really tell you about that.
I have to ask our scientist who's not here. Are the measurements linked to any like a profile that you set up for yourself on your farm? Like if a farmer would use that, do you have a profile already so that you don't have to do the localization and all of these things?
Sure. So we've trained it on a variety of soils across the UK, meaning that when you go and do a sample, you don't have to do that localization. The only thing that we would advise people to potentially do to contextualize their results is measure it from the margins of their field. So go to somewhere that's undisturbed, because that's the soil in its natural and therefore healthiest state. And so if the results you get in field are closely equivalent to what you get in the margins, you can say, okay, this soil is performing to its natural optimum. But if you're far off, then you can say there's still a lot of work to be done for it to be performing at its healthiest.
Okay.
Has it been independently assessed for accuracy?
So the way we did the independent assessment was working through Innovate UK to do the project. So we basically worked with NIAB and with other partners. They did the testing for us. We then basically had the machine learning expert from University of Essex put the information together, and that's how it was done, because it wasn't us that developed the algorithms, it was actually through the work with the University of Essex that it was done.
Has that been published and peer reviewed?
Because the way that publications work, we're just waiting for the last parts from NIAD to be done before we publish articles on it. So we're just waiting on the go-ahead from them.
You're just placing this on the ground, are you? What do you do? How are you actually doing it?
So you put a soil sample in here, and that's it. You can carry it around. I mean, I've left it on the table here because it's easy, but actually you can walk from site to site.
Okay.
So basically you start the tests, and you don't have to stand there and wait for it to be done like we're doing now. You can start the test and start moving on to your next location and start sampling from there. The only thing we don't advise is putting on the back of a quad bike or a Jeep at the moment.
The vibrations are not that great.
Yeah, well, no, because if it bounces. So
Yeah.
the way it's done is the soil sits here and the sensor sits up here, and you don't want the soil hitting the sensor, which is why you can walk around a bit. It's better than that. But if you're bouncing around, it might hit it and cause short circuits on the sensor.
Yeah, okay.
So you don't have any reagents?
No. The technology we used is a world's first technology, and it's very much based around, I mentioned the idea of smell, but basically volatile soil life can, like all life, produce a variety of metabolic byproducts as gases or volatile organic compounds, and it's actually that which is being detected by the sensor. We've developed a device to be looking at a variety of different families of volatile organic compounds. So in essence, it works like a dog's nose. And in the way that you can train a dog to smell for truffles or narcotics, that's exactly how it works with here. It kind of goes, okay, you've got all these this data set of lab data that you did throughout the years. Can you actually provide me the results on those? And again, if we didn't think that actually would be commercially viable to be an accuracy level enough, we wouldn't be providing it as a commercial product to you all now. So the important thing to note is that we've launched this year. We've been doing demos and trials throughout this spring. We are providing the first units to customers in September, and we have a limited run. There are only 50 of these available this year because we're still a small startup. We can only produce so many, and once they're gone, there won't be any more until next spring. So if you're interested, please do come and talk to us, and we'd love to be able to tell you more, and potentially even do do a demo on your farm to prove it works on your soil, because really that's the litmus test, right? Being able to, it's one thing for me to do a demo here and show you how it works, but the real litmus test is going onto your farm and making sure to show you how it works there. Absolutely. So test complete.
What's the confidence? Do you mind showing the sense of similarity with conventional tests for the 12 things? You obviously tested it conventionally, tested on this to make sure it was right. I mean, how close do you get
when the results come
conventional testing?
So the test accuracy that we have is between the high 80s to low 90% accuracy based on the lab results.
Well, for everything.
And so then you get
pretty much.
You get no variation on the 12 different.
So I think some of them might be sort of slightly lower in the mid to high 80s, and some of them, like microbial biomass, are very much in sort of the low to mid 90s. Because it's a biological based test, it performs a little better on the biological ones rather than necessarily the chemical physical. But it's still good enough level of accuracy to be commercially viable.
So for the chemical ones, it's also looking for volatiles as well.
Yes, so basically the way it works is that the volatile, it basically finds the volatile profile of it, and then we've over a number of years we basically tested hundreds of samples for the volatile profiles, as well as for all of the indicators that are listed there, and that develops our calibrated data set.
You get a list of
and then what
indicators
works is
coming
basically the software goes, okay, so I found this profile,
there's a little
and I know from this calibrated
description
data set that these results are X, Y, Z for these indicators.
Do those calibrations need to be updated?
No, they don't. We do constantly work on improving the calibration and adding more data into it.
Would you be subscribing to a program?
No, so you basically you buy how it works commercially.
There's a description.
You
We
buy
use
this
an index
unit,
bin as well,
and
so
it's £3,000
we
per
divide
unit.
all the data
And that's a
into
one-off
8
purchase, a
bins.
bit like a mobile phone.
Those at the extremity are
And
larger.
then
Those in the
this cassette
in the
has
main
100
area
tests.
are
It goes behind
more
the
detailed.
panel of the unit here. So you take it out after 100 tests, and you pop a new cassette. You pop a new cassette in, and we've done it so it's £25 per test basically. So there's 100 tests at 2,500, but it means that if you're testing at volume, so if you're testing 100 tests, it ends up actually saving you money over doing, let's say, a soil health test at laboratory, where there might be about £70 per test.
So it's one of them plus one of them, or
Yes.
one of them comes with one of them?
Yes, indeed.
One
So
of
you
them
have,
comes with one of
yeah.
them.
So when you buy one, you buy one of these, but it would come with one of these as well because you can't do less than that.
£2.5 grand's worth of tests with your £3,000.
No, so you'd buy, it's basically £5,000 because you'd buy this and you'd buy the cassette as well.
Right.
But we are providing a launcher discount to people who adopted early, which brings it again down to that only £5,000 for both of them.
Yeah. I reckon that's going to come down over time.
My head of commercials looking at me, so I have to keep mum.
Right. I think the £3,000 to me is doable, but I'm not sure about ongoing cost. I think that probably makes me steer towards using a lab still. Whereas if I just paid, I'd probably rather pay £5,000 for something that I could do a million tests with forevermore. I think that element just sort of throws me off a little bit.
Fair enough.
Have you done any comparisons with like time of day, wetness of soil,
So we have done
temperature, things like that?
So it does look at wetness of soil and looks at humidity as well. So there's a humidity and temperature sensor in here. So it's calibrated for different temperatures, different humidities. We haven't done different times of day yet, but it is something that we would very much like to do, because actually it'd be very interesting to see if soil patterns behave differently in the morning to the afternoon.
Really hot soil that's had mucker 6 weeks ago, it might give off a different smell than
Exactly. And I think one of the key things with us is when you do a lab test, it's a bit like doing a snapshot in time. Whereas because all the results are GPS logged and they're relatively easy to do, you can start looking at the trend data. So you can go to one point and you come back next week and the week after, and you can see how it's doing. And so there's the question of accuracy, but ultimately, soils vary within a plot. The key thing is actually how it trends over time on the individual plot.
This is the way I'm, and a lot of other farmers are actually starting to do it now. The actual results, because I've had terrible lab results that be completely wrong from people exhibiting here, top rated laboratories. So you go away from that field is that field is how you go away from what is that point in time? Is it more, is it less? And you make a decision.